All right, time for the culminating video of this entire marathon of a unit. Making 5 of these videos is too much in one day. Okay, anyways, so we have word problems. And now I know word problems are not everybody's favorite thing in the world, but this is where things actually get interesting. Whenever you ask that question, where am I ever going to use this in real life? Word problems is the answer to that, because word problems is all about drawing the real life scenarios around what we do. Now, sometimes they make no sense because we're making up a question just to test the data, but other times they might be applicable to a specific profession. But anyways, that's generally speaking the goal. So word problems involving vertex and factored form. You'll notice that we're not doing anything in standard form. If we had standard form, we could always factor it to put it in factored form. So we'd be right back to where we started, factored form. So when working on quadratic word problems, it's important to decide which form to actually use. How do we know? Should we use the vertex form, y is equal to a times x minus h all squared plus k? Well, we should if we're given the vertex and at least 1 point. Okay. Now, maybe we're not given it very clearly. Maybe we have to read the information of the question and it will be kind of hidden inside of that information. That doesn't mean it's not there, though. Now, when are we going to use factored form? Well, remember what factored form is. Y is equal to a times x minus r times x minus s. R and S represent our x-intercepts. So we're going to use the factored form if we're given our x-intercepts. And again, at least 1 point, which may or may not be hidden in the question. Okay. Now, when we do these are still word problems. So we should be sure to use let statements to introduce any variables and draw a picture if needed. This I highly recommend, because sometimes we're not fully understanding the problem, and drawing it out to visualize it would help immensely. Okay. Now, I want to be clear though, when it says be sure to use let statements to introduce any variables, there are times in the question where the question itself already describes the variables. So we don't need to do let statements for variables that already exist. That's redundant and a waste of your time. So let's get into this. I'm going to turn to highlighter mode here, because it's important that we highlight the key information. A football player kicks a football held at 0.5 meters above the ground. So it's starting at 0.5 meters above the ground when he kicks it. The football reaches a maximum height of 30 meters at a horizontal distance of 18 meters from the player. Okay. Determine the relation that models the height of the football relative to the horizontal distance it's traveled. Now, this is where we have to step out of our comfort zone, because we're not always going to be dealing with x's and y's and whatnot. Now, I can choose to, but I don't have to. You're going to see in other questions that the variables are not always just going to be nice x's and y's. So let's start off with this. Our goal is to determine the relation that models to the height of the football relative to the horizontal distance. So let's let x be the horizontal distance of the football. So let x be the horizontal distance of the football. That means that let y be the height of the football, or vertical distance, be the height of the football. What that basically means is, if we know how far the football has moved, we should be able to calculate its current height at that moment. So our goal now is to kind of put all this together. First of all, what are we given? Are we given vertexes? Are we given x-intercepts? Well, look at the question. A football player kicks a football held at 0.5 meters above the ground. That's not on the ground, so we don't know the x-intercept there. But we do know that it reaches a maximum height of 30 meters. Whenever we see that word maximum, when we're talking about a quadratic, we know that that represents where the vertex is. That's the x component of our vertex, a y component, the maximum height of 30 meters. And it does so at a horizontal distance at 18 meters from the player. So since the player is where we're kind of starting at. Let's draw a little picture here. All right. So imagine that we're kicking the football like so. All right. We have the distance of the football and we have the height of the football. Okay. Now it starts off at a height of 0.5 meters. Okay. But we know 18 meters down the field, now my scale is not perfect, but 18 meters down the field, it's going to hit a maximum height of 30 meters. So right about there. So if we're to graph this, okay, this is basically what the trajectory of our football is. We can drop this down in here. So we're given the vertex. And that vertex is located at 18, 30. So we can substitute this into our equation to get the start of everything. So we get y is equal to a times, and now remember, this is our vertex form, so x minus h. H in this case, remember, h represents the x component of our vertex, which is 18. So x minus 18 all squared plus the y component, which is 30. Okay, but now we need to get a still. So in order to do this, just like we did before, we need a point. We need a point on the curve. Do we know any points that aren't the vertex? Yeah. We know the starting point. That starting point, we know that it was located at x is 0, because that's where he starts kicking from, and a y value of 0.5. So we can substitute that in to try and figure out where we're at. So we have 0.5 equals a times our x value, which is 0, minus 18 squared plus 30. Now put this through, we end up with 0. We can bring that 30 over to the other side now, so let's do that. So 0.5 minus 30 is going to give us negative 29.5. And that's going to be equal to 18 squared. You might have to pull your calculator out for that one. So it's negative 18 squared, which is still the same as 18 squared, which gives us 324a. 324a. Now we're going to divide both sides by 324. It's not the easiest term in the world, but we end up with a is equal to negative 29.5 divided by 324. And that gives us approximately 0. Let me write that again, just to make it a little bit clearer. We could rewrite this as a is approximately 0.09. Honestly, it depends on the question and how you want to do it. It depends whether your teacher asks you to keep everything as perfect numbers or whether approximate numbers are okay. So you'll have to determine that based on the situation, what makes sense. So in this case, we'll show both. So therefore, y is equal to our a term, which is negative 29.5 over 324 multiplied by x minus 18 squared plus 30. Or we could do it with the decimal, which would be y is equal to, that should be negative. That should be negative 0.09. Negative 0.09 times x minus 18 all squared plus 30. Okay, so that's what the question is asking for. Now, once we have that information, we could start doing other types of questions as well, such as what was the total travel distance of the ball and things like that. All right, let's do another one. A toy rocket is launched into the air from a cliff. Okay, so let's imagine we have a cliff here. All right, and it launches the toy rocket into the air from the cliff, and it reaches a maximum height of 500 meters after 3 seconds. The rocket falls to the ground after 8 seconds. Now remember, this is a cliff, and the ground is over here. So it's getting launched, and eventually it's going to hit the ground. Okay? Now, after 3 seconds, it hits a height of 500 meters. So we think about this. This is a height of 500 meters, okay? And after 8 seconds, it hits the ground again. So there's our picture. So what does this mean? How does this help us? What kind of information does it give us? So the toy rocket launches into the air from a cliff and reaches the maximum height of 500 meters. Are we talking about vertex form or are we talking about factored form? Well, we're given the vertex again. We know where its maximum height is. So we know h and k, 3 and 500. 3 and 500 what? What are our x and y components here? We didn't do any let statements. Do we need to? No, we don't, because if you read the question, it says develop a relation that models the height of the rocket h relative to the time t. So that tells me that this axis is t, and the y-axis, the y-axis, which is normally the y-axis, this is going to be our h. So we don't actually have to have let statements. We just need to use them, okay? So let's rewrite our equation. So that means there's no x's and y's, there's h's and t's now. So that means h, which used to be our y, this is going to get confusing for a second, is equal to our a times our x, which is now our t, okay, minus our h term. We can't use h anymore. This is where things get confusing. So we have to use what we know. In this case, what is our h when we hit our maximum? Well, h is I'm trying not to confuse you here. H represents our vertex's x component. Remember, x is equal to h. So this is going to be t minus 3. And that's going to be squared. And now we got to talk about our k term, which is the y value of our vertex, which is 500. So that's what we're looking at right now. So let's go rewrite that over here. H is equal to our a term multiplied by t minus 3 squared plus 500. Okay? Now, if it makes your life easier and you want to use x and y, you can do that. You just got to make sure that you got to get it back into h and t at the very end, because that's what the equation's actually expecting. Okay? Alrighty, so with this information, can we do anything else? We still need to get our value for a. Well, we can do that. Look at our picture. What other location do we know? We know it hits the ground right here. It hits the ground at a t of 8, and on the ground, its height is 0. So we have another point. So we can substitute this in. We can sub in 8, 0. So this is going to be 0 is equal to a times 8 minus 3 squared plus 500. So that's 0 is equal to, well, actually, let's bring that 500 over the other side. So we have negative 500 is equal to 8 minus 3. That's 5. 5 squared is 25, so 25a. So what is a going to be equal to? A is going to be equal to exactly negative 20. So now we can substitute. So therefore, h is equal to our t, we forgot our a term. The whole point of doing that, all that work. So negative 20 times t minus 3, all squared, plus 500. That is the equation for that rocket, that toy rocket. So we should be able to find anything we need to. So given any time, we should be able to calculate its height. Given any height, we should be able to calculate the time that it hits that height at, just by substituting those values in. So it says, how high is the cliff? Well, what is the time t when it's on the edge of the cliff? Well, the time t is 0 at that time. So what this is really asking is, what is h at t equals 0? That's really what's being asked here. So what we need to do is just substitute the value of 0 in for t. So we have h is equal to negative 20 times 0 minus 3 squared plus 500. So that's negative 20 minus 3 squared, that's 9. Negative 20 times 9, that's negative 180, but we'll write the whole thing in. So negative 20 times 9 plus 500. So 500 minus 180 gives us 320. What is this? This is the height of the cliff. This is the height when t is equal to 0. So therefore, the height of the cliff is 320 meters. Don't forget your units. How high is the rocket after 4 seconds of its launch? Again, this is another question. What is h when t is equal to 4? So we just substitute. So we have h is equal to negative 20 times 4 minus 3 squared plus 500. Well, 500, not 50. So 4 minus 3, that's just 1. 1 squared is 1. Times negative 20 is negative 20. So that means that the height of this is going to be 480. 480 meters. So therefore, the rocket is 480 meters high after 4 seconds. There we go. So all these problems are basically the same to start with. Some of them may get a little bit more complicated. So let's take another step forward here. Where did we go here? Yes. So imagine this scenario. Imagine you're playing soccer for a second. So a goalie held a soccer ball 0.5 meters above the ground and kicked it. The ball reached the maximum height of 42 meters at a horizontal distance of 22 meters from the goalie. Now, this question here is basically exactly the same as the last question. So if you're following along in this video, pause the video for a second, try and go through and solve this on your own first. So I'm going to draw a picture because I always like to start these things with a picture. Okay. We're given, again, our variables, develop a relation to the model height h and the ball relative to its horizontal distance x. So x is still x in this instance. So this is x and this is h. Okay. Now we know that it kicks it from a 0.5 meters above the ground. So that's at 0.5. Okay. And the ball reached its maximum height of 42 meters. So somewhere up here at 42 meters. A distance of 22 meters from the goalie. So 22 meters from here. So right. Give or take, right about there. What is that telling us? That's telling me the vertex. The vertex is located at 22, 42. Okay, so we know the vertex. That tells us that we should be using the vertex form version of problem solving. Great, good to know. So if we follow this, it's going to hit the x-axis somewhere down here. Okay. We don't know when, we don't know where, we don't know any of that. So all we know is where the maximum is. Okay, so let's do this. Let's substitute. It says develop a relation. So the first part of these questions is almost always going to be develop the relation, because we need that in order to solve all the other problems. So let's substitute our h and our k into our equation. So our y, we don't have a y anymore, so now it's h is equal to our a, we don't know a, and then it's going to be our x minus the x component of our vertex, which is 22, squared, plus the y component of our vertex, which is 42. Great. So now we have that information, but we need to get a. So we need another point. Do we know any other points? Yep. We know where it started. It started at 0.5, comma 0. Oh, I got that backwards. 0, comma 0.5. Try that again. 0, comma 0.5. There we go. So we're going to substitute those values in. So the height of 0.5 is equal to a times 0 minus 22 squared plus 42. And 0.5, let's bring that 42 over to the other side. So that means we're going to have negative 41.5 on the left-hand side. I'm waiting for my computer to catch up here. And then we're going to have 22 squared inside, which is 484. My computer's not catching up with me here. It's slowing. Give it a second. It's just lagging out. There we go. So we have negative 41.5 on the left, which is equal to negative 22 squared, which is going to give us 484a. Now, we'll write that out. A is equal to negative 41.5 over 484. Not the best number in the world. So we could say approximately, or A is approximately negative 0.086. So, now, let's pause for a second. This is absolutely accurate. There's nothing wrong with this. Now, sometimes people will want to get rid of the 0.5 in here. It might make the math later on easier for future questions. If that is the case, you can absolutely do this. If I doubled this number, I'd end up with double the number on the top and double the number on the bottom. So I could write this as A is equal to 83 over, oh my goodness, the software is not the best. $83 over 9, double the 484, we end up with 968, negative, sorry. 968. So both of those are perfectly acceptable, and so is the 0.086. So the question is, what do you need at a given time? That depends on you. So let's write this out. So in one option, I have therefore h is equal to negative 83 over 986 multiplied by x minus 22 squared plus 42. Or we could write it as h is equal to approximately negative 0.086 times x minus 22 squared plus 42. Okay, so those are acceptable. It all depends on the scenario, the problem that you're trying to solve at any given moment. So let's go on to part B. How high is the ball after traveling a horizontal distance of 15 meters? So again, this comes back the same as the previous question. What is h when x is 15? That's what it's asking us here. So h is equal to, we'll use our equation. So let's say, let's use our fraction. Negative 83 over 986 multiplied by x, so 15 minus 22 squared plus 42. So we end up with, now this 15 minus 22, that becomes negative 7 squared. That's 49. So 49 times negative 83 over 986, and then we're going to add 42 on that. You can put that into your calculator, and what you're ending up with is something around h is equal to approximately 37.8 meters. So we give a therefore statement. Therefore, the height of the ball after 15 seconds, or sorry, after 15 meters is approximately, now I want to use that word approximately because we are making a guess here. Not a guess, but a rounding, I should say. 37.8 meters. Okay. At what other distance will the ball have the same height? You're like, what? How does that work? there is a number of ways to approach this problem. Now let's think about what we're talking about here. We're saying that after 15 meters, so 15 meters, right about here, it had a height right there of 37.8, okay? Ish. 37.8 meters. Pop, 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 pop. So the question is asking, what other x value also had 37.8 meters at a height of 37.8 meters? Now, there's actually quite a few ways to solve this problem. There's a very simple way, and then there's a much more complex way. The simple way says, well, 15 is how far away from the midpoint. Remember, we're talking about a symmetrical curve here. How far away from the midpoint is 15? It's 7. So if we went 7 on the other side, we should end up with at the exact same height. So that would give us a value of 29, if that is the case, right? So that'd be 7 plus 22. So that's the easiest answer. But is that the only answer? Is that the only way to get that answer? So the question breaks down to is, what is the height? What is x? What is the x? Sorry, not the height. What is x when h is equal to 37.8? What we're seeing is that x is going to have two possibilities. And we see it's at 15, but then we just go to the other side and we get the 29. That is, again, the easiest way to do it. Alternatively, we could just do the math, okay? So if we write this out, if we substitute h of 37.8 in, 37.8 into this equals our entire equation, so negative 83 over 968 multiplied by x minus 22 squared plus 42. Solve for x. Oh, yeah, I know what you're thinking. But yes, this is still what we're looking for here. So that means we're going to bring that 42 to the other side, and we're going to end up with negative 4.2. Okay? And that's going to be equal to negative 83. Negative 83 over. Now, I should say approximately at this point, because that 37.8 was approximate. So this whole thing is approximate. 968 multiplied by x minus 22 squared. X minus 22 squared. Next thing we have to do is we got to get rid of this fraction. So we multiply by, we get it over to the other side. That means that since it's being multiplied here, it would be divided down here. That'd be the same thing as saying negative 4.2 divided by negative 83 over 968. That's the same thing as negative 4.2 multiplied by 968 over negative 83. Oops, negative 83. The negatives go away, and we end up with a ridiculous number, and it ends up to be approximately 48.98. 98. I don't know why I write 99. So I can write that over here. I can say 48.98 is equal to x minus 22 squared. Right? Now, if I take the square root of both sides, that means that, remember, it could be both positive or negative, because when we do the square root, it could be in either direction. I want the positive and negative version of 48.98. And on the other side, we have x minus 22. And then we can bring that over to the other side. That means, what is the square root of 48.98? That's pretty close to 49. So we could really say, remember, the whole thing is approximate already, so we keep approximating. So the square root of 49 is 7. So plus or minus 7 is equal to x minus 22. Now we can bring that 22 to the other side, And we have, in one direction, we have 7 plus 22 is equal to x. And in the other direction, we have negative 7 plus 22 is equal to x. So x is equal to 29. Oh, that's what we're looking for. And x is equal to 15. That's what we already had. So that means the one we're looking for is that guy. So which option are you going to choose? Are you going to choose the option where we simply look for symmetry because we know that it's a parabola and we know that we have an axis of symmetry, so what happens on the left also happens on the right? Or are you going to go through all of this math and approximation? Hopefully you make a choice that's much, much easier. But anyways, we still need a therefore statement. Therefore, the other distance with a height of 37.8 meters is 29 meters. So perfectly legitimate, but I would recommend using the strategy on the right. That's going to be 1, maybe 2 marks. And if you're doing all this work and so much potential for error because of these numbers, it's definitely a better approach to go with the first option. All right, let's keep going here. Example number 4. Now this one is finally an equation that isn't somebody kicking something or somebody launching something where there's something flying through the air. Now we just have generally a shape. So imagine a tunnel, and that's 50 meters wide, and it has a maximum height of 40 meters. How high is the tunnel when it is 5 meters from its base? What do we mean by its base? Well, imagine that you drew a picture and it looks like this. Okay? Now, the tunnel starts here at 0, 0. Does it have to? Not necessarily, but I'm choosing for it to do that. And I know that it is 50 meters wide. So somewhere over here at 50, it's going to touch again. Okay? And the tunnels are arches. So we know that it hits a maximum height at 40 meters. Where is it going to do that? It's going to do that at the midpoint. Well, what's the midpoint of 0 and 50? That's just 25. And it's going to hit that point at a height of 50. Sorry, not a height of 40. I was reading the wrong information there. Height of 40, and the whole thing is 50 meters wide. So a height of 40. So right about here, we have our tunnel. So this location, we actually know, where that is. We know that vertex is at 25, 40. We also know where it's actually, where it's touching both sides on the ground. We know that it's touching at 0, 0. And we also know at 50, 0. So the question comes, should we use vertex form or should we use factored form? In this case, we could actually use both. You could use either. You could use factored form or vertex form. We have a vertex, right? We have points, lots of points to work with. We also have both x-intercepts. So because of that, we could use either. Now, we haven't done a factored form version yet, so I'm going to use the factored form version so we can see it in an example. So imagine we have our factored form. Y is equal to a times x minus 0, or x minus h. Sorry, not h, r. Getting ahead of myself here. X minus r and x minus s. Okay? Now, what do all these things represent? We didn't do any let statements, so we better start with that. So let's say let x be the width of the tunnel, or the distance from the base of the tunnel. Let x be the distance from the base, or the start, the base of the tunnel. And let's say let y be the height of the tunnel. There we go. So now we have our values, and we can substitute what we know in here. We know the x and y intercepts. So we have an x-intercept of 0, and we have another x-intercept of 50. So we can substitute y is equal to a times x minus 0 and x minus 50. Okay, so let's keep going. So we can simplify this a little bit. Let's see here. So we can get rid of that 0. We don't need that. So that's just y is equal to a times x minus 50. Does that substitute? Does that solve everything we need? No, we still need to find a value for a. So what we're going to do is we're going to substitute one of the points we need, or one of the points we know. We don't want to use the 2 points that we used for the x-intercept. So the only other point we know is our vertex, so 25 by 40. So we're going to substitute that in here. So we have 40 is equal to a, so sub 25 comma 40. All right? Times x. What is x? X is 25 times 25 minus 50. Okay, so we have 40 is equal to a times 25 times 25, that's 625, because 25 minus 50 is negative 25. So that's actually negative 625. Well, I don't want to write it like that because that's going to look like a minus 625. So we're going to fix that. So it's negative 625a. Now we're going to bring that negative 625 to the other side, and what we end up with is not the best thing in the world. We're going to end up with a is equal to negative 40 over 625. We can reduce that to negative 8 over 125. Or we can say a is approximately negative 0.064. Okay, so let's give an equation. Let's keep our numbers exact though. So therefore, y is equal to negative 8 over 125 multiplied by x minus 50. Okay, so there's our equation. Now it says how high is the tunnel when it is 5 meters from its base. So we're looking at this. When this is 5, what is the height? So our goal is to find y when x is 5. So we substitute. So y is equal to negative 8 over 125 multiplied by our x is 5 times 5 minus 50. So that's negative 45. Not the best, but whatever. So this 5 can cancel out with this. Actually, we'll just put it right there. So y is equal to 5 times negative 8. It's negative 40 over 125 times negative 45. And we end up with y is equal to about 14.4 meters. So therefore, the height of the tunnel at 5 meters from its base is 14.4 meters. The height of the tunnel, 5 meters from its base, from the base, is approximately 14.4 meters. There we go. All right, one more question. Maybe two? Yeah, one more question. So this is another similar one, although the question is going to cause a little bit more thinking involved. So an arch at the end, an arch at the entrance to a tunnel is in the shape of a parabola. Makes sense? The shape of the arch can be modeled by the relation h is equal to negative 0.5 x times x minus 16, where h is the height above the road and x is the horizontal distance, both in meters. So they're actually giving us the relation. So we can draw the picture here. If we think about this whole equation, h is equal to negative 0.5 x times x minus 16. If we think about it in terms of factored form, what we're really seeing here is h is equal to negative 0.5 times x minus 0 times x minus 16. What that tells me is that its x-intercepts are at 0 and negative 16. Or sorry, 0 and 16. So I know exactly where or how wide that tunnel is. I don't really have to think about it or anything like that. We can even draw a picture of it. So we go from here. We start at 0, and we know it's going to hit at 16 over here. All right. So we draw this tunnel. It's going to look something like this. It's asking what is the maximum height of the arch. So how do we do that? Well, basically it's asking us for what is the height of the vertex. It's asking us what is this height. All right. But that means we need to know where the x value is as well. So what is the maximum height of the arch? What is where h is the height? So h and x is the distance over here. What is h at the vertex? That's what we're doing. So in order to do this, we need to find the midpoint between our two x-intercepts. Well, that's easy enough. So our midpoint is going to be equal to 0 plus 16 divided by 2, which is equal to 8. Great. So we know that that hits at exactly 8. But now we need to find the y value at the same location. So what can we do with that? Well, we can substitute. So we can substitute this value back into the original equation. So we have h is equal to negative 0.5. We're going to substitute our x in there. So sub in 8. So our 8 times 8 minus 16. So that's going to be equal to negative 0.5 times 8 times negative 8. So the negatives are going to cancel out of here. So we have 8 times negative 8. That's negative 64 times negative 0.5. That's just going to give us 32 right on the button. So that tells us that our vertex is located at 8, 32. That's good information to know. So therefore, the maximum height of the arch is height of the arch is 32 meters. Great. What is the height of the opening at a distance 2 meters from the base of the arch? So basically we want to know if this is 2, what is the height at 2? So this just comes down into substitution again. We're going to substitute a value of 2 in for the equation to solve for h. Okay? So h is equal to negative 0.5 times 2 times 2 minus 16. And let's calculate. So 2 minus 16, that's going to give us negative 14. Times 2, that's negative 28. Divided by, or times negative 0.5. So negative 28 times negative 0.5 is going to give us exactly 14 meters. So we know that that's 14. We know that that's 32. Okay. Therefore, the height of the tunnel at 2 meters from the base is 14 meters. All right. A truck is carrying a large crate 6 meters wide by 23 meters high. Can the truck pass through the tunnel? So this is where it becomes a little bit of thinking. We have to understand the fact that in order for that truck to make it through, the largest truck possible, or any truck going through, if it's a big truck, has to basically drive right down the center of the road. That's going to give us the biggest height possible, because if it's over too far to the left, the arch hasn't had enough time to actually increase in height. Same with the right. So we have to drive straight down the center. So what we're basically looking at here is if the truck drives across here. Okay? So what is that height that we have to deal with here? So we know that the truck is carrying a large crate that's 6 meters wide. That means that the whole thing is 6 meters wide. So what does that mean about each half here? That means that each half is going to be 3 meters. It's going to be 3 meters wide from the left to the right. 3 meters this direction and 3 meters this direction. So what does that tell us about these points? We know that they're 3 meters from the 8 meter mark. So that means that this one is going to be at 5, 0, and this one is going to be at 11, 0. Huh, okay. So if we know those values, all we have to do is calculate what is the height at those values. They're going to be the same height because it's symmetrical. What is the height at 5 meters? If it's less than 23, the truck will pass through. Less than or equal, if it's greater than 23, then the truck will be able to pass through. If not, the truck's going to hit the edge. There's no way around that. Okay, so our goal is the height, is the height of the tunnel at x equal 5 larger than 23 meters? That is the question. Is the height of the tunnel at x equals 5 larger than 23 meters? So let's substitute and find out. H is equal to negative 0.5 times x, which is 5, times 5 minus 16. Okay. So we have negative 0.5. We'll leave u alone. Leave the 5 alone. And now we have 5 minus 16. That's going to be negative... that should be negative 11. I'm looking at my notes right now, and I definitely have the wrong thing written in my notes. So, let me just go verify my notes real quick. Yeah, so there's an error in my notes. I'll go back and fix those. I don't know how I made the error. It's just an arithmetic error. Anyways, so this should be negative 11 here. And so that means we have negative 0.5 times negative 55. Well, when you do that, you end up with 55 divided by 2, which is going to give you 27.5. H is equal to 27.5. So that means it's going to be 27.5 at 5 and at 11. So the question is, does that fit? Well, 27.5 is definitely larger than 23. So therefore, yeah, the truck can pass through the tunnel, no problem. So since 27.5 is greater than 23, therefore, the truck can pass through the tunnel. And there we go. And that's the end. So if you look at all these problems, they're all basically the same thing, right? We didn't really do anything special. We figured out we either had the relation for the arch or we were given the relation for the arch. They're all parabolas, right? And once we have that relation, we're just solving extra questions based on the information we're given. And it's usually substituting some value for the x or some value for the y, and then sometimes connecting some ideas like we saw in part C of question number 5 there. We had to understand the fact that in order for that truck to pass through, the maximum area it's going to be able to deal with is if it's directly in the center. That tells us to divide the rectangle by 2, so we know exactly how far away to go from that center point. So we have to use some common sense as well as some basic understanding and critical thinking in order to solve these problems. So that's it. That was definitely a longer video than we planned, but that's the end of this crazy long unit. See you for the next one.